Now we are dealing the discussion of statistical introduction, that is how the frequencies are actually represented. Frequencies are represented in two forms. One is group frequency, another is ungrouped frequency. Ungrouped frequency means the data are given in isolated form, like number of goals per match and number of matches. This idea, this is 0, 2, 5, 6. The number of matches is 8, 12, like 3 and 2. Now this type of frequency is ungrouped because these figures, number of goals, isolated number, that means discrete number, this is x we denote, and the number of matches, number of occurrences is frequency, how many matches we are finding. Now from here we can ask some question like how many matches at most 2 goals are scored. At most means maximum, that means 2 or less than it will be. And when I am saying at least, then that will mean minimum. So if I say how many matches at most 2 goals are scored, at most 2 goals, that is 2 goals or less than 2 goals. So the result will be 2 goals scored, 12 matches, less than that 0 goals scored, 8 matches. So answer is 20. So if I ask you at most 2 goals are scored in how many matches, then your answer will be 2 or less goals are scored. But if I ask you at least 2 goals are scored, then you have to take in this table 2 or 5 or 6 goals. That means 12 plus 3 plus 2 is 17 will be the answer. This is the idea. Now come to the next point, that is how we see grouped frequency. Grouped frequency means, what is the concept of grouped? Group means class interval. When we see the class interval, that is in some groups, there are two types of group frequency classes. Grouped frequency distribution will be two types of groups. One is overlapping groups and the other one is non-overlapping groups. Overlapping and non-overlapping, this is a very important point. What is overlapping? Overlapping means when the classes are made, that is groups are made, like age group I am writing, age 0 to 10 years, 10 to 20 years, 20 to 30 years, and how many persons are there? Suppose this is 5, this is 8 and this is 3, this is given. But on the other hand, I am seeing number of marks obtained, marks 0 to 9 marks, 10 to 19 marks, 20 to 29 marks, and number of students maybe 3, 7 and 2. These two types of table we are seeing. This is also grouped, this is also grouped. But in the first case, left side, what I am discussing, if you look at the group is 0 to 10 and then 10 to 20 overlapping. But on the right side, if you see 0 to 9 then 10 to 19, this is non-overlapping. Now these type of classes are considered to be inclusive class. Inclusive means 0 to 9 both are included. This marks means number of students 3 students means they have scored from 0 to 9. That is it. Some student may have scored 9 or some students may have scored 0 among these 3 students. And then 10 to 19, this is inclusive class. But on the other hand, this side 0 to 10 age means that means the persons, 5 persons, 0 age just born, maximum less than 10, that is 0 to below 10. Why? Because it is overlapping, because 10 will be considered in the next group, 10 to below 20. So this is exclusive. Why exclusive? Because in this group we are not include 10. Upward extremity, this extremity in the upper side will be excluded, and in this case both the ends are included. but we have a name in this for these extremities. The lower extremity and upper extremity, this is lower and this is upper. This overlapping means boundaries. This is called boundaries. Boundaries. And these are called limits. So what is the difference between limits and boundaries? Boundaries are always overlapping. That means 0 to 10, although it is seems to us that 10 is included here, no, 10 will be included here. This is boundary. And when I am writing 0 to 9 and 10 to 19, the 9 will be included there, 10 will be from there. So this is the concept of inclusive and exclusive class. Now if you consider which is better, I would say class boundary has some advantage. Why? Because in considering the class length, when you want to know class length, the length of the classes, we better always will take class boundaries. That is upper class boundary minus lower class boundary. This is called class width or class length. So what is class length? Class length is not from the limit, it will be from the boundary. Now if I tell you find the class length of these classes, 0 to 4, 5 to 9, then 10 to 14, etc. So what are the length of these classes? These class lengths cannot be considered unless and until we take the class boundaries. So it will be minus 0.5 to 4.5. Why? Because class boundaries are overlapping. So take the concept of 0.5. Increase this side by 0.5, this side by 0.5. So it will become minus 0.5 and that will become plus 0.5. That means minus 0.5 to 4.5. I tell you, this is a very awkward idea I am discussing. I'll tell you why it is awkward. Next, 4.5 to 9.5. Then 9.5 to 14.5. This way we make the classes. So classes are now becoming it's a boundary concept, means overlapping concept. How we do this? Whenever we see that limits are given, means these classes are not overlapping, we just adjust normally by 0.5. But why I have given the bracket? Actually minus 0.5 looks very awkward. That's why we write normal 0. I am writing minus 0.5 to make it clear. What is the length? 4.5 to 9.5. Class length is 5. 9.5 to 14.5. Class length is 5. But minus 0.5 to 4.5, yes, it is also 5, because 4.5, actually what is happening, 4.5 upper boundary minus 0.5, so your answer comes to 5. Actually it is 5, because other cases you see, other classes, 9.5 minus 4.5, 5, 14.5 minus 9.5, 5, and here it looks not very simple, because minus 0.5 we normally don't write, we write 0, but that is a mistake. We should remember that it is actually adjusted. 0.5 will be adjusted, so the length will be 5. We can do this way also. You count 0, 1, 2, 3, 4 inclusive. So start from 0 and count up to 4. So you will be finding 5 class length is 5. This is the idea of class length. Now how to find out how many classes we will be taking? How many classes? Number of classes. So number of classes I am writing n. If I consider the number of classes, will be class frequency divided by length of class. Sorry, range of the class. Sorry, range of the data. Range of the data by class length. So once more, what is the formula for class length? Class length, number of classes. Number of classes is range of the data. What is range? Lowest value minus highest value minus lowest value. What is range? Range is the difference between the smallest number in the data, in the statistical data, subtracted from highest data of the statistical collection of data. That range divided by the class length, will be getting the number of classes. Now taking an example. Class length, I am taking an example. Some figures I am giving and wanting to find what will be the proper class length. Now see, find number of classes, find number of classes, and data are given as the marks are like that, some scores are like that, 60, 28, 73, 18, 82, 38, 50, uh, then 45, then 52. This way figures are given. So if you look at the figures, then what you are finding, one more data, 20 and suppose 79. Now first thing, what is the range of the data? How many classes? If class length is 10, that means I have to mention find number of classes for this data. If class length will be, each class length is 10 units. So how to find out the length of class is 10, then how many classes you have to take? You'll be telling, how do you know that class length is 10? That is normally decided according to the nature of data. So it is 10 units, it may be 5 units, it may be anything else. Now what is the number of data, number of class length, what will be the number of class length if you want to find n? Will be range. Range means highest value. Highest value in this data is 82 and lowest value is 20 divided by 10. So you come to 6.2. Lowest value is 20 and highest value is 82. So it is 62 divided by 10, 6.2. So you have four options. A is 5, B is 6, C is 7 and D is none of these or whatever it is. Four options are given. Now question is, how many classes will be there? Now as a common idea, as a common concept of mathematical sense, we will be telling 6.2 number of classes makes no sense. So we'll take the approximate value and that will be 6. So we'll choose the option B. But this is not correct. Remember one very important thing, number of classes can't be in decimal, obviously, which is number. So what we'll do, we'll always take for the decimal answer the next figure, next integral value or next whole number. Don't take 6, it will be wrong because you have to include all the figures. So number of classes will not be 6.2, will not be 6, number of classes will be 7. This is the idea. Answer will be 7. Why 7? 6.2 in normal mathematical approximation is not considered to be 7, but since it is a statistical requirement, we will take the next figure and the next figure means answer is 7. That is all about how many classes we will take. Now come to one more idea. When this is frequency, we can have cumulative frequency, means frequencies will be added from the top or from bottom. That means there may be two types of cumulative frequency. Cumulative frequency means classes are given, class intervals are given, 0, 10 to 19, 20 to 24. Let it be like this: 25 to 29, 30 to 39, 40 to 44, and 45 to 54. You will be objecting to this. You will be raising a complaint. That is not right. I am coming to that point. 3, 7, 8, 5, 4, 2. Now this is looking very awkward. This is called unequal class length. It can be possible. Unequal classes are not impossible. What is cumulative frequency? Actually, cumulative frequency means frequencies to be added. It means the values less than up to any particular class. In this case, you apply your common sense. I don't want to make it longer. The discussion I don't want to make very longer, because this topic, this introduction of data, statistical data or description of statistical figures, I think you can use your common sense. Cumulative normally means less than particular value. That is called less than cumulative frequency. But it may be more than cumulative frequency also, which will be added from below. There are two ideas: added from above or added from below. So we normally take cumulative frequency as less than cumulative frequency. That means number of persons or number of cases up to, less than this class, less than 19. That means up to 19, how many are there? It will be 3. Just keep on adding. Simply 3 will be starting, then 3 plus 7, 10, then 3 plus 7 plus 8, that is 18, then 3 plus 7 plus 8 plus 5, 23, then 27 and then 29. So this is the total frequency. That is the idea. We will start from the first value and keep on adding. 3 is cumulative frequency less than, it is called less than. Then 3 plus 7 is 10, that is cumulative frequency 10, that is less than 24. Actually this is less than 90, 19, 3, and less than 24, 10. And this way we have added these frequencies and we got the cumulative frequency. This is called less than cumulative frequency. I have one more point, frequency density, which is very important. Many times we have seen this question, frequency density, and that is class frequency by class length. Very important, class frequency by class length. Normally unequal classes, that's why I have given this example, because this frequency density is a different question, but it is important for unequal classes. So suppose I am asking what is the frequency density of third class. Third class means 8 is frequency. Look at the third class, frequency is 8, third class. But what is the length of the class? Length of the class is 5. Why 5? 24.5 to 29.5. Mind it, 24.5 to 29.5. Why not 29 minus 25? 29 minus 25 will be wrong calculation because it is not overlapping. We should take the class limit to be converted to class boundary. That means 25 to be converted to 24.5 and 29 converted to 29.5. So obviously the third class is length is 5 and frequency is 8. So your answer will be 8 by 5, that is 1.6. This is the frequency density. This is the idea of frequencies. Some more ideas may be there, but this is basic. One last discussion about when you see the data, just normal data without any frequency or occurrences, but you have some figures. Like I can say one example for this moment, this contemporary discussion, that is of course the idea of this corona. Different states are having different corona patients, so we can show in pictures. There are three things we can discuss. One is what is the nature of number of corona patients. It can be discussed with straight line, increasing line or decreasing line, it is going upward, or the number of patients going downwards. This is discussed in straight line, that is called historeogram. Remember the word I will discuss in previous later discussions, historeogram or line diagram. But if I ask you which state are having more corona patients, we show normal idea is bar diagram. But if you want to compare the different categories, this businessman, then professionals, then workers, this category want to compare, then we show pie diagram or pie chart. This is very important, pie chart. Pie chart is, bar diagrams are like this. This is bar diagram. States are there. This is West Bengal. This is Orissa, like this, number of corona patients. This is like Chennai. This way we will show the number of corona patients. This is bar diagram. These are all separated rectangles. This is not histogram. We will discuss histogram in later discussions. Now the last point is, what is the pie diagram? Pie diagram means 360 degree total. Total 360 degree. So if you ask me the angle, how much angle we will draw, that is 360 degree will be divided in the proportion. Like if I say there are three states ABC. In the first state we are finding 200, means 200 crores persons are there. Second state is 300 and third state is suppose 100. Now if you ask me what is the angle for the third state, what will be the angle for the third state, C state? So total is 600. So what we'll do, 600 total will be total 360 degree. This is the idea, unitary concept. 600 total population represents 360 degree. So if I want the C, what will be the angle for C? That is 100. What will be the angle for 100? Use that idea of unitary method, 360 by 600 into 100, and you will be getting 60 degree. This is the idea of central angle. This is called central angle. So what is central angle? The angle which represent the data. A will be represented like A is something like this. A is this. A will be suppose something like here, B is there, and C is there, like this. This way. I have not drawn the figures according to this figures. I have not drawn this one. This is an example. You know this diagram. This is called pie chart. This diagram, what I have drawn is a hypothetical diagram from my mind, but actually the angles will be measured and then we'll draw the angular measurements. This is all about first topic, more or less I have discussed. That's all.